Hello everyone, hope you all doing well. Myself Sushmita, currently pursuing my BE degree in Sri Venkateswara College of Engineering, having USN1 VE 22 CS 165. In this video, I am going to explain a topic on stack and stack operations. It is related to the data structures. Firstly, welcome to my presentation. So here are the topics that we are going to discuss today. That is stack operations, implementation of stacks using arrays, then applications of stacks. Firstly, what is stacks? A stack is abstract data type that is popularly known in the most programming languages. It is named stack because it has a similar operations as the real world stacks. So here's for example, pack of cards or a pile of plates. Then a stack is a linear list of elements in which an element may be inserted or deleted at only one end. Here we are going to insert the list of elements or we are going to delete the elements by only one end called as the top of the stack where we are going to insert or where we are going to delete the elements that is called as the top of the stack. Then stack is a data structure which works on the principle called last in first out, that is LIF. That is, this is nothing but the last element that we are entering will be the first element that we are going to delete it. So we are going to arrange the elements in an order. So the last elements that we are going to enter, it is on the top of the stack, will become the first element that we are going to be deleted from the stack. Here is the representation, that is a stack ADT allows all data operations at one end only at any given time. So we are going to allow data operations at only one end. We can access the top element of the stack. We can only access the top element. This there is a following diagram that represent the stack and its operations. So here one diagram is push and one diagram is pop. Push is nothing but we are going to inserting and pop is nothing but we are going to deleting. So here we are inserting the elements in a hierarchical order. So the last element that we are inserting. So in pop the it is the first element that we are going to delete it. So last in and first out. This is nothing but push and pop. So only top element we are going to inserting and it will become the first element that we are going to delete it. Next, stack operations. Stack operations usually are performed for initialization, usage, and deinitialization of the stack ADT. Here are some basic fundamental operations or push, pop, overflow, and underflow. Push is nothing but inserting an element into the stack. Pop is nothing but removing or deleting an element from the stack. Overflow, check whether the stack is full or not. Then underflow is nothing but check whether the stack is empty or not. Let me discuss the one by one. First, it is insertion. Insertion is nothing but push. Push is an operation that inserts element into the stack. The following is an algorithm that describes the push operation in a simple way. Here is the algorithm for push. In step 1, we are going to check if the stack is full or not. Then step 2, if the stack is full, it produces an error and exists. If the stack is full, we can't insert any more elements, so it produces an error. Then in step 3, if the stack is not full, increment stop to point next empty space. It increments the value of the stack by 1. So if the stack is not full, it increments the value where it increments on the top of the point. Then it adds data element to the stack location where top is pointing. So where the space is pointing, there it adds the element on the location. So in step 5, it returns the success. Deletion. is nothing but pop. Pop is a data manipulation operation which removes elements. So deletion is nothing but pop. Then pop is a data manipulation operation which removes the element from the stack. The following pseudocode describes the pop operation in a simple way. Here is the algorithm for pop, that in step 1 it checks if the stack is empty or not. Then if the stack is empty, it produces an error and it exists. Then step 3, if the stack is not empty, access the data element at which top is pointing. So if the stack is not empty, it accesses the element that which is on the top. That means the last element entered. So after it is pointing, after accessing, it decreases the value of top by one value. Then after in step 5, it returns the success. Then overflow, it is the third operation. Overflow operation checks whether the stack is full or not. This operation is used to check the status of the stack with the help of top pointer. This operation checks whether the stack is on full or not. Here is the algorithm for this also. That is in step 1, start. Step 2, if the size of the stack is equal to the top position of the stack is full. Then returns 1, otherwise it returns 0, then end. Then underflow, the underflow operation verifies whether the stack is empty or not. So in overflow, we are going to check the stack is full or not. In underflow, we are going to check the stack is empty or not. This operation is used to check the status of the stack with the help of the top pointer. So here is the algorithm for this also. That is step 1, start. Then step 2, if the top value is -1, the stack is empty. So the top value is -1. I have told in pop. So in pop, we are going to remove the top element, then we are going to decrease the value of the stack. So -1. So if we are removing, then the top value will be -1. So the stack is empty, then it returns 1. Otherwise, it returns 0. Step 4, end. Here is a C program to implement stacks using arrays. That is, we are going to define the size, then size of top is equals to -1. We are going to define the push pop display, then printf 1 dot push, 2 dot pop, 3 dot display, 4 dot exist. Then we are going to printf, that is enter your choice, scanf for that, then switch cases. Next is the applications of stacks. Stacks used in function cells, stacks used in conversion of expressions, that is arithmetic expressions, then evolution of expressions, that is an arithmetic expression can be represented in the form of prefix or postfix. I'll tell you what is prefix and postfix. And stacks is also used in recursions. Here are some more applications, that is Polish notations. And arithmetic expressions can be of three types, that is infix expression, prefix expression, and postfix expression. In infix expression, placing the operator between the operands. Here, the plus is the operator and A and B are the mine operands. So we are placing the plus in between A and B. So we are placing the operator between the operands. So next is prefix expressions, that is placing the operator before the operands. That is before A and B we are going to place the plus. Then postfix expressions, placing the operator after the operands. After A and B we are going to place the operator. That is nothing but postfix. Infix, prefix and postfix. These are the Polish notations, and one more applications of stack. Then thank you. Thank you for watching my video.